I've chosen this particular example for two reasons. One, because it's a vertical example of a vertical motion, and the other one is because it has a b as a constant. The motor has a parabolic displacement, and the velocity can be found by differentiating this function. So we can do this and we'll get b minus 9.8 t meters per second. And to show that its initial velocity is b at time 0, we will have initial velocity. We'll just insert time to be 0, and when we do that and we multiply it by 0, we get a value of b meters per second. And so we have just shown that the initial velocity of the shell is b meters per second. And it is a known fact that the velocity at the top is equal to 0. This will be the maximum value on the displacement function, and that will be the slope of the function of velocity, means that the velocity slope must be 0. We know that the maximum height is reached when velocity is 0 after 7.1 seconds. So when velocity is equal to 0, we get maximum height. And that height is going to be of 7.1 seconds. So let's insert that time into our velocity of 7.1 seconds, and that means it will be b minus 9.8 times 7.1 seconds. So b minus 9.8 times 7.1 is equal to 0. In other words, b minus 69.58 is equal to 0, and in other words, b is equal to 69.58. Now b is a constant. Now that we know what b is, we know that our two equations will be 69.58 t minus 4.9 t squared, and we will know that the velocity equation will be 69.58 and minus 9.8 t. And as we are to find the initial velocity of the shell, which is number 1, that will happen at time 0 and 69.58, and we'll substitute the 9.8 with here and t with 0, and we'll get a value of 69.58, and as this is velocity, it'll be meters per second. And as this is a vector, we need to indicate that it is upward. So an arrow will surface over here, just putting an arrow, or we could just say up. Now to find the maximum height reached by that ball, we know it is at time 7.1 seconds. So we use the displacement function at 7.1 seconds and insert the values, or substitute the values for t, which is 7.1 minus 4.971 all squared. And using the calculator, we'll just find the value of that being 247 meters. That's it.